welcome. All right, so welcome to our event, and for those of you who haven't joined us before, welcome to the Virtual Space Program. My name is Kimica, and I won't be presenting today, but I was one of the coordinators who helped with the planning of this event, and I've been either a presenter or coordinator on every English VSP event in the last year, so I guess I'll be the one giving the opening announcements. For those of you wondering, VSP is a mostly Japanese group, and we don't do that many events aimed at English speakers. This is definitely one of the first times, if not the first time, that we've done an event with the Japanese presenter and Japanese to English live translation that's specifically aimed at English-speaking audiences. So we are very excited to have you here on this hopefully not terrible day. Yeah. We'll be going through 2 particle accelerator-related worlds today with a guided tour led by the world creators. So the first world shows the Atlas detector at the Large Hadron Collider. That's where we are now. And the second shows the SPring-8 synchrotron radiation facility. So, where is... Yes. Georgeus here will be presenting for Atlas. He made this world. And S. Asagiri will be presenting for SPring-8. He made that world. Ebigunso will be providing translation support for S. Asagiri in the next world. We're still waiting for them to arrive right now, I think. And Endeavour was the coordinator who helped with the planning of this event on the Japanese side. Cat Love, where is... Cat Love will be live streaming this event, so please be mindful of where their stream camera is. Please do not get between them and their camera and the presenters. And something I need to explain, I know that I need to explain this from experience, the culture surrounding World Tour events is often quite different in English VR communities, where it's more normal for those to mostly just be a social event where people just happen to be moving around. So just know that our expectations are possibly quite different and possibly quite a bit stricter compared to what you're used to. In short, we expect you to be paying attention to the presenters, and we require you to not interfere with other people's ability to pay attention to and learn from what the presenters are saying. I've gotten in the habit of preemptively explaining my expectations in rather specific detail, so unless the presenters say otherwise, I would like to ask you to abide by the following. 1, do not push buttons unless event personnel explicitly direct you to do so. 2, if someone is actively presenting something, go far away from the main group if you need to have some side conversation unrelated to the event topic. 3, if someone is actively presenting something, hold your questions until the presenter asks for them. 4, do not place or use stickers or items, especially items that make noise. Prints relevant to the event are okay. 5, set your avatars to a reasonable size, not more than 1.80 meters. Do not use avatar sound effects and stow any large accessories such as wings, horns, or tails. 6, dress appropriately, as in choose clothes that would be appropriate if you're going to a non-virtual space museum, or, well, a particle accelerator. 7, do not use copyright infringing avatars. Anyways, that's all I have to say about that topic. I promise you that this will be fun, and that you will enjoy it, and that you will learn cool things. I just had to get that out of the way. Are you excited?
Yes.
Buddy.
I am ready, boss.
Good. All right. Well, then, in that case, let's turn things over to Georgeus, who will start the tour of this world.
Thank you very much, Kim. So, many of you might not know me. Many of you might. So I'll tell you a little bit about me. So my name is Georgeus, or George. I am a CERN associate. I work there, and that it also makes me a little bit proud to say that today's event is affiliated with Atlas and the detector part. So those people know that we're here, and they specifically asked me to send them a screenshot or a small video of us being here. So I'm very proud that we got this many people joining us today. And everything you're going to see here is 1-to-1 scale replica of a real thing. So feel free to walk around the rooms and feel to exist there. We'll have time for that as well. But by the end of the tour, and also I'm free for you to come and ask questions after we are done with it. We'll have a small announcement after we go through all the parts there, and then we're gonna make a big warning where that will make you know that we'll be moving to the next stage, which will be SPring-8. So I'm pretty sure you already got acquainted to where we are right now, which is 100 meters above the detector. We're going to be taking this elevator, which is a teleporter elevator, to the downstairs 100 meters. So I want to ask you to stand in line. So we'll be going in an elevator and descending there, where we will wait for everyone to get down, and then the real thing will begin. So thank you very much for joining. I'm very happy to see this many people yet again. So let me just wait for the translation. And
Actually,
or
well, the person who is going to do the translations isn't here. We're going to wait. We're just going to run the Atlas part of the tour, and then while we wait for them to get here.
oh, sure, no problem. Okay, then I will be opening the elevator, and I'll ask everyone to get in there. It's a little bit tight.
しまったん
He
だ。
close, he close, he close.
How many people at a time should be in the elevator as it goes down and goes up?
あれI don't...
And what's spawning in?
Already be here?
All right, hold door open. Okay. Oh, all right.
Let's wait for everyone here.
Wow.
Too many people on the room, on the elevator.
There we go.
Oh my! I sure hope you all got Avatar calling on. That is a lot of people in a small space.
And just
It's not all bad.
Endeavour might have just crashed.
Curiously enough, I have everyone unlocked, and my friends are fine.
Where is...
Yeah, so
Is Cat Love here?
I'm here.
An avatar limit on.
Okay.
Mm-hmm.
All right, everyone listen
Okay.
up. We're going to resume now.
Okay, so please follow me.
Okay.
And herein behold, Atlas detector in its full scale. This is what it feels like to be there.
I know it was big.
I think this is a great opportunity to take the first good picture.
Amazing.
Okay,
All right.
I'll give you a minute to breathe. Okay, so, well. Here is the Atlas detector. This is where we simulate the conditions of Big Bang. So now, who wants to tell me what happens when particles collide? What goes on in very first moments of the collision? Who loves physics in school? There we go. That's correct. They break into smaller particles. There we go. Well, we have this situation here that we collide protons here, around 40 million of them in a second, and those 40 protons give birth to new particles. Smaller particles, or even bigger particles. Now, who knows what Higgs boson is? We have one guy over there, and the other guy, no problem. So, I want to ask Kimica to give me one of the Q pens there, so I can give a very small explanation of it. So, this is the particle detector, which is a big cylinder, but I'm gonna have it, imagine this is the detector, and a particle collision happens here, and when that happens, a lot of particles go to different ways. depending on their charge and depending on their energy. They stop at different places. So they might stop here, they might stop somewhere here, or they might go all the way above it. And depending where they stop is how we know how much energy they have. And if they stop here, that means they had small energy. That means it's a smaller particle, like an electron. It stops here, on a layer here, it means it's a proton. And if it goes all the way in the end of the detector, for example, this one, it's a particle called muon. So this right here is a muon detector. Now everything what I said can be seen on that blackboard, provided officially by Atlas. Okay, but enough of me boring you with this thing. Let's move. Let's move to the side C, which is there.
Do you want to take a group photo first?
We can take a photo here or on the other side. Up to you. So both. Let's take one group picture. Why not?
Everyone get in.
I think this as a background would be nice.
Oh. Yeah, see it this way. Oh, it's good. It's good.
Yeah, this will make a nice wall poster for my computer.
Alright, taller people stand to the back.
Right.
Taller people stand to the back.
Yep.
I'm lagging a bit.
Squeeze it a bit. Yep, I'm tall. Sorry. Okay.
Face that way. Face that way. Okay. Let's see.
While we're trying to take group pictures, I will also add that here, imagine the densest place in the world where nothing can escape that enclosed space, not even a particle. Well, that's what engineers at CERN have achieved here. So, all this is necessary to make sure that nothing escapes this detector, not even a single particle. So all the energy is contained.
Right. I guess we're ready to move now.
Correct.
Okay.
Alright.
Okay. Follow me. And so as you move from side A to side C, you will see those cylinders and a lot of pipes. They are holding liquid helium and liquid argon. I want to ask again, does anyone know why do we want to reach absolute zero in the cooling? Okay, well, yes.
Because the particles will move that much at absolute zero.
Yes, you're very close.
Isn't it about the electricity?
Yes.
That in order to accelerate the particle, the electricity need to flow at maximum speed.
Exactly.
And only a
Exactly.
superconductor-
There we go. That's the right.
It does.
Exactly.
Yeah.
So we have two variables here. One being electricity, and the other one being magnets. So one is responsible for the speed. I don't know how I don't know how to write S on the other one, and the other one is for the direction. So we have a circle here, and you know when we're moving very quickly, like almost the speed of light, it's really hard, you know, to maintain the angle. So we have magnets that have magnetic field that fix that, and they make the particle angular. So the stronger the magnets are, the better the angle is, because they shouldn't touch anything, because if they touch something, they collide and they explode. Oh, explode. A small particle, but still they explode. And with the electricity, we need a lot of electricity. And if we cool it down to absolute zero, then we get something like this. Electricity or energy equals to, well, energy of the proton divided by resistance, right? Anyone remembers something from physics? But if the temperature is absolute zero, then resistance is also zero. And what happens when something is zero? And what's the limit? And what's the limit of that energy? It's infinite.
Goes infinity, yeah.
Exactly. We get infinite energy. There we go. But, well, you cannot really get infinite energy in real world. So it's 99.997 of the speed of light. Slow. But not close enough. But it's fine. We're building right now the new collider, 100 kilometers long, which will be completed in 2069, and that will have almost, well, it's probably 99.9998 of the speed of light. So who knows? No, I want to erase all this. There we go. Okay. So, right now I want to invite all of you to the elevator that does not exist. This is the only thing that's not authentic. They don't have elevator there, but I put it there so that none of you have to walk up the stairs. Although by all means you can. Yeah, but when certain people were here, they were very nauseous, so I thought it was necessary to add an elevator. Now, the entry to the elevator is actually from this side. It's a little bit confusing, but it was the only way to put it there. So I'll open the door for you all. But the fun thing is that this is a real-time elevator. So it moves in real time. So please go ahead.
Go in and it goes up.
Oh my god. There's people
So I want to ask all of you to look at the detector while we do this, because avatars might juggle a little bit. So,
¿Les quieres estar listo para hacer cosas?
I want everyone to look. Yeah, but,
Just in case.
Sure. Okay. Okay, so there's 3.
Just in case.
Okay, I'll just wait for the door to close.
I see.
Slow.
Just don't move. It's okay. It's okay.
Oh, it's
Yeah.
okay.
Okay.
Oh.
Yes, Kimica. Yes, Kimica.
It was
is not the
fast.
floor. So I guess we're moving to floors with stairs anyways. So you'll have this experience as well. Move slowly.
Oh, there it goes.
Interesting. The elevator.
Oh,
Okay, okay.
is
One more floor. One more floor. Okay, there we go.
There's a hole, man.
This is
Yeah,
the-
quite it right there.
Okay.
I'm off route.
It says it's the fifth one, but it's not. But sure. Okay, and here we're gonna move back to the side A with this very small connecting platform. So here you see even more of those cylinders with again liquid helium or liquid argon. Very tight space. might I say. Okay, now I need to stop. So, for all the ones who are very brave, I'm inviting you once we finish to go there and try to reach the top of the detector. But we'll do that afterwards, after we're done with this route. Now follow me for now. Now, this is the door where people enter the detector room in real life. So this is the view they are greeted with. Now, I don't know how used to you are, but when people come here for the first time, they get this sense of height.
Mm-hmm.
And very first time certain people saw this, they were quite, they got the fear of heights. And they also got very nostalgic.
Sorry.
Right. Now, to not be squeezed, so that to make sure that not everyone is squeezed here, so let's go upstairs, 3 more floors, and go all the way to the top. People in real life have to struggle, so you'll suffer a little bit as well.
Just a few floors.
Still cannot
he's
give
like
away in cyber world.
I don't mind doing this in a virtual world.
Wow.
Have you ever worked in a multi-floor shop where you have to go through like 5 floors?
This is so
50
hard,
times a day?
guys. My favorite Yuki.
Wait.
Yeah, I need to breathe out.
May I ask a strange question?
I had legs of steel at the end of that job.
Do you like really actually have to run all of this every day in real life?
Well, you mean the virtual tour or the real tour?
No, the stairs.
No, not really. I mean, there is a very tight elevator there, but I did not add it here because it would like fit 3 people at most. And also very few people are permitted. So everything that we did today is just not allowed in real life. It's not allowed to be down there. It's not allowed to like walk around just like that. And also it's not allowed to be present without a proper protection hat. So from all of us, I think Kimica is the only one who would actually be allowed. And it is quite like representation of the uniform they have to wear. So he gets a pass. Okay. Okay, so now we look at the detector from this specific angle. Pretty cool, right? And you can ask me more questions, but I'll also clarify one more thing. So to run this thing, we are spending a lot of money, and I mean humanity. Okay, guys, like this. The mission of CERN is to bring humanity the treasure and move the humanity forward. The CERN was established after World War II as an attempt to fix and to redeem people from all the terrible things that happened in the World War. And so far, I want to say a couple of achievements that was made while trying to research this. Something that we use every day, but it was developed specifically for this purpose. One of them being the very thing that we're using right now to communicate. Who knows it? Who knows what I'm talking about? The thing that makes all of this possible.
Would be the internet.
Yep. That's it. It was a very nerdy thing for them to communicate with each other because it was terrible to you can't really call someone from 100 meters below, right? So they developed a local network that then became a global network. Another one would be the touchscreen. they were tired of pushing buttons on a big ass thing, so they created a touch screen so they could have a UI. Then the electro thing that scans your body, the MRT, if I'm pronouncing it correctly. MRI, yeah, MRI. I would argue that X-ray too, but I'm not really sure about that one. So that's the thing. So this costs a lot, and it might only give us the information about smallest particles that we might not really use, not even see or feel. But while researching this, we are developing something that's truly unique and something that's pushing us as a humanity forward. AI was also one of the things that started here, but that was in 70s. And even up to today, they're doing big innovations. And well, I don't want to brag much, but something that just the fact that this thing can also run on Android. So any of you, if you come here on a standalone version, if you have Quest 3 or Pico, you'll be able to see this in its full scale. And those methods were developed by me personally, and that's also one of the achievements that CERN has. That now they have a VR version, for publicly available one, that people can come and enjoy. Thank you very much for joining me. Now, I'm open for any kinds of questions, be that physics, math, this one, VR. Or you're free to walk around and explore it at your own volition. We'll put down the warning sign, the announcement that we're moving to the next instance once the time comes.
Before we do that, group photo.
Right.
Yes. Group photos are important. Okay. The way we're going to do this, half of you are going to go down to the platform below us, and then the cameras will be over there. Sort yourselves out.
Which row?
For the questions, I do have one. You said earlier that you use the magnetic field to maintain the particle.
Maintain the angle.
You said that,
yes.
Yeah. What would happen if it was to like weaken and hit the side and just get blasted? Would it actually break the machine, or it would just blast itself as a particle?
Gather along the rail.
It will blast itself as a particle. And the thing is, we are very careful with our data. So if we put 400 million particles, we just launch them like a missile, we expect the energy to be equivalent to that. So energy in should equal energy released. That's the only way we can be sure that we don't have a leak. Yeah, although that always happens.
Okay.
So you know
that
they reached the end.
Gather along the rail.
Exactly. So
along the rail.
Everyone gather
the
along the
number
rail.
of
Yes.
radioactive
Okay,
particles
let's-
are much more smaller than.
Also, I have a math question, but
Over there.
I think.
Wait, it's
Yes.
moving.
There are no
Like,
significant damage.
when you give
It's
Like,
vertigo-inducing.
no, that's very small damage. So
it's okay.
Yeah.
when you give that equation where the denominator was the friction, heat, and like if you have it near zero, basically, and you make like a limit thing. Wait, now it's like pictures.
Yes.
Sorry, can you?
Yes.
Okay.
Like just how feasible it is on the amounts of quote unquote free energy that such a thing can bring just by being like near zero.
Well, free energy, I wouldn't call it free energy, but it allows us to have, I think, 120,000 ampere of electricity wiring there without, anything burning down.
Okay.
I remember when it started, there was one thing that went amiss, and it just blew
Okay.
up.
Did we get all the photos that we want?
Maybe.
Hopefully, maybe.
Oh
Who
my god,
knows?
he's moving.
Hopefully.
He's moving.
Yeah, I do have an Easter egg here where if you go 3 floors down, you can walk on that rail and then jump on the detector. Yeah, you can do that. I made it possible because I like people interacting with scientific stuff.
Okay. I assume the group photos are done now. Everyone can go explore.
Also, small joke that I missed to say about the hats, the safety hats. So one of the Atlas representative was here that I was showing her this, and the very first thing she told me as a feedback that why isn't everyone wearing a safety hat, huh? That doesn't feel authentic. You should definitely add something for a safety hat.
Go back up.
I didn't do that.
Come in.
As you see. because adding safety hats to every member would add so much polygons it would break my optimization on a standalone version. Yes, do you have a question?
Is there a place I can put my head in where the particles would pass through it?
I have that, but that's in a separate world, which is not part of the store. You can hit me up.
Okay.
You can hit me up with like invitation, and I can show it to you post factum. Yeah, that's my second project, which we'll be showcasing later. It's the insides of the detector.
Is that the same part that one dude actually put his head into, or is that?
No, it was in Russia. This is in Switzerland. No heads were put in this detector. No.
That's good.
I hope.
Is this where the particles come out?
Quite frankly, also the detector entry and visits are not prohibited, but like not allowed for majority of the year, because that's probably one of the only places you will see this thing that you see those signs that like warning, high voltage. Well, here you see warning, radiation, do not enter. And I don't think that's something that people want to enter in. So a lot of, even if you go to Geneva, for example, when I went to Geneva my first time, I couldn't go there. So I was going around showing them this thing, and they're like, yeah, actually a lot of people come here and we just can't let them through. So it's nice that you have this, it's going to make them feel that they're there.
They can see it in VR.
They can feel it. That's the important part. I mean, they do have some 3D videos, but you cannot feel it. And in the future, I'm planning to add here the simulation, the visualization of the particle collision itself, so you can see them moving around and scattering. And I want to make sure that
what caused the radiation? You said there's a warning for radiation, but is it using? Is it because of the clash of the particle?
Yeah. Oh, okay. Yeah. So the radiation and the energy here are used interchangeably.
Yeah.
Sorry, it's meant to.
Yeah.
Oh, no, you
so
that's what
I don't have coupons here. Okay. So how this happens is that, scientifically saying, when particles collide, the way we stop them is by absorbing their energy, by absorbing their radiation, the energy that they emit. And if you all remember the Einstein's formula, E equals mc squared, where C is a constant, we can remove it, we get E equals to m. So with the energy we absorb, we can determine the weight, mass of the particle. So that mass that that the electron has, the proton has, it's actually the energy it was required to stop it entirely, that we named the mass. So you saw, if you remember the picture that you saw on the board down there, there was a collision and the particle stopped somewhere. So this detector is divided by layers: electron layer, hadron layer, and muon layer. And depending on where they stop are the types of particles we identify them as. Also, there are like antiparticles, but I don't think this is the part of that.
That's a can of worms.
That's a can of worms even of itself. I will say one more thing that I learned recently on one of the lectures at CERN, that, so again, I'm going to get slightly more nerdy here. Protons inside have quarks, 3 quarks, 2 up and 1 down quarks, but there have been sightings of particles that have 4 quarks, 5 quarks,
Okay.
but they are not unique or elementary particles. So, and those are mostly the theoretical things that are not fully proven. So I'm not gonna state it as a fact. Just treat it like a very positive estimate. Yeah. What
Would they be
right now?
Would they be random occurrence because of the collision, or
The most honest answer I can give to is I don't know. Yes.
Yeah, I have a question. How many how do you say it? Minovsky particles do you guys detect?
I have no idea what you're talking about. So
It's a Gundam reference.
It's a Gundam reference.
Yeah. I see,
Hopefully
yeah.
none.
Now I get it. Yeah, there is an upgrade going on there. So in a year or so, there will be an upgrade, and they will be hitting it with bigger mass, bigger energy. So maybe we'll find something new. Yes, Tim?
Nice.
You had a question?
Oh yeah, I put my hand down because then I realized it might not be a great
It's
question.
okay.
But,
There aren't no great questions. There are no stupid questions. Only stupid people. Yeah.
So I know that we theorize that a graviton exists. Would this
Yes.
machine have the capability to detect it if one came into it?
I don't think so. This was specifically built for small elementary particles, which are electrons, muons, and bosons. Actually, the Higgs boson, not gravitons. No.
Okay.
Yeah, and the Higgs boson. Right. There are particles that cannot exist in this world stably, so they decay. They only exist for a very fraction of a couple of milliseconds or even nanoseconds. And they appear and then they disappear. We never get to trace them. I'm sorry, we do get to trace them, but we never get to detect them. So how we do that is that we trace them. So if we find electrons with very specific energy under very specific angle, then we can assume that it came from something bigger, which is called the W boson or Z boson. And if they align perfectly according to our patterns, then we can say that, okay, so this was from Higgs boson. So when the collision happens, Higgs boson appears, divides mass, then decays into W and Z bosons, and then they decay into electrons. And well, some people are, I'm going to theories, saying that, it's very much possible that in that collision, in that moment, where do you get a mass? Because mass didn't exist, then suddenly mass exists. The people think that there is a way that a small portal is opening in a parallel universe, and Higgs boson appears, pulls energy from there, and then it distributes it here. But we don't know that, but I'm very interested in that. There were 2 main theories that were fighting with each other while Higgs boson's mass was discovered, and those were supersymmetry and multiverse. So there was this funny thing that we had a mass of 115 gigaelectron volts and 140 gigaelectron volts. And if the mass of the Higgs was below the first one, we would have a supersymmetry. We would be living in a world of supersymmetry, which has its own laws. But it's something like every particle gets its own symmetrical particle. I'm not going to get into that, but it was something very cool. And on the other side, there was a multiverse, which is also very cool, but not really, because that means that we're nothing special and there are unlimited versions of us. But the Higgs boson, can you hold your hands like this for me? I want to ask you, does anyone know how much Higgs boson weighs? How much mass of the Higgs boson is? Okay, so I need Kimica to come here and put his hands right here, like this.
Like, do I
like
stand
me, like
facing you
me?
or yes.
Yeah. So, so from his left would be supersymmetry. From his right would be multiverse. So I'm gonna put my finger where how much the mass was and where we landed. Come closer.
Yeah,
there's the wall.
Okay. Well,
It landed somewhere exactly here. 125 giga electron volts, which means none of those are true. Yeah, because that means that the answer is not that easy. It's more complicated than you think. It's a little bit complicated. We have to dig forward. We have to dig deeper. So we decided to build a bigger detector. Of course, why not? Yeah. That will be 100 kilometers long. Right now, they're trying to develop how do we even do this, because we don't know how to pull it. We don't know how to properly operate it, but we're digging.
I'm not dead.
Digging under Geneva.
Oh, yeah, thanks for coming.
Yeah, and we'll see. It will be finished in 2069. Yeah.
That's a bit of a far date.
Or maybe 2060, but I don't remember. But it's not gonna be here anytime soon.
I'm gonna be a grandpa by that time.
This is gonna be a hell of a story for our brain.
If I don't make it to 90 years old, you'll be happy.
I mean, I don't know. Maybe with AI, we'll be able to do it faster.
Engineering with it could be possible.
All right. Now it's really it. I have exhausted everything I wanted to say. So now I'm ready for more questions. And if we don't have any more questions, just what time is it?
It is 10. It is 10:50 JST, so we should be moving to the next world soon.
Okay. Yeah, we should be moving there in presumably 10 minutes.
Depends.
Depends on the people.
And should we move?
Actually,
because like
next?
Sorry, actually, I have a question. Why is it we have to wait for 2069 for the new thing? Like, what makes it long? If you can answer that, yeah.
I don't have the answer, like definitive answer. It's not like something is stopping us, but I think the people at Geneva have researched it, logistics and all of that, and they arrived to this state.
Oh, okay. All right.
It might be sooner, it might be later. There is no definitive way of saying that this is the year, but that's what they say. The estimate, most realistic estimate.
That's why it takes 10 years to make a fab.
You
build
have
a
your
fab for
own
precision.
personal
But
theories
I
that
guess
you've come to
30 more
regarding
years because of
the
bureaucracy.
accelerator.
Well, my
Like
own
fun
personal theories. Well, you see, in 2012, when the Higgs particle was discovered, some people wrote it down as a God particle, or particle of the God, and that I was 12 by then, so obviously it was a very cool thing for me to hear about. But then, as more I uncover and the more I learn, I really start to realize that how do I say this? That the reality is stranger than the strangest of fictions. So knowing how it works, and the more questions I ask, it's actually not a very smart thing to ask questions here, because not only do my questions decrease in quantity, I also not get an answer on them most of the time, and I end up having even more questions. But that's something that people here encourage, because when you only by realizing that you don't know anything, you can say that it's a sign that you're learning. Even Einstein said that he was just not smart enough, and if only he knew math properly, he would have solved a lot of things that he wish he could. And it's just something to say about us as a society that we tend to think. The more you know, the more you think that the less you know.
Oh yeah.
Very true.
Okay, let's end the questions there. We need to move on to the next world. I have a portal ready. If you all could move forwards to clear up.
I mean, we can always stay afterwards.
Yes.
Well, if you have more questions.
Yeah. Okay, everyone, move off to one side so I can place the portal.
Silver Sword really tries to say something. Yes.
I just want to understand what's about that.
Okay. Yeah, I was gonna ask that too.
Like all the way up.
Yeah, what's there?
Okay.
A tube, because we're 100 meters underground. It's a big pipe.
Probably a bunch of
and all the way up is where we came from.
Thankfully, this world is just you
Okay.
can teleport to players.
Is that how they get things down here?
Alright, Jamina, I'm gonna take my leave now. I'll catch you next time.
Thank you very much for coming.
Thank you very much.
Thank you. You're a real scientist.
Thank you very much.
Where are they going now? Is that how they get things down into here, like big, large items?
Exactly. Yeah, with a big ass crane.
Next part
Yeah.
of the tour. This is the next part of the tour. We're actually doing 2 worlds. This is so this is the halfway point. Get ready.
Okay. All right. Yeah, I assume. Okay, everyone go in.
At least you didn't come out with your head the other way. I can trade all.
It's a fair trade. Further than the neck.
Okay, everyone.
Right in the grid to get here.
Oh my.
Okay, everyone.
And someone else's left foot.
Okay, where's the QB? I need a QB pen. I need a QB.
You are here with not. Okay.
Originally, you was couple of days. There will be people who can check the Energy Physics University of Japan. Yeah, and I'll be showing this to them. Like, I don't know, should I show this one to them? Maybe I should show this to them as well. I just want your permission. Because I don't think they'll be able.
I didn't understand.
Wait,
what
if this isn't immediately
okay, it's okay. I'll have it translated to you.
Okay, so it seems like the people that we were expecting to have helping us with translation stuff are not here, so as I understand it, Asagiri will be trying to just present in English directly for everyone, but he made this world. Please be patient about any potential translation difficulties, but yeah, also
we'll live with it.
Here, if you get lost, there is a list of players here, but like there's a teleporter system, so just click the name of whoever you want to teleport to in order to teleport. Also, I should probably say this again for anyone who came in. Please be mindful of the live stream camera. Cat Love is live streaming, so do not get between the live camera and the presenter. Got it?
GG.
Okay, great. I think that is all I need to say. So just please give Asagiri-san your attention, and avoid having side conversations close to the core group. Thank you.
Okay.
All right. Yep, let's go.
Okay, I am Asagiri.
Is a song?
And here is a SPring-8. What is a Japanese accelerator. In the second part, I will experiment sorry, I will experience the detail about this accelerator. As Kimica-san said, originally I was planned to talk in Japanese and would be translated by a translator, but today we don't have a translator with unknown reason. So today I will try to talk in English, and my English may not be so good. So if you have any unclear part, please do not hesitate to ask me. Okay?
Yes. Yes.
Okay.
Yes. Although your English is quite nice.
Thank you. Okay, start from this scaled model. This is a scale model of this accelerator. This accelerator is not the same with the last one, LHC Atlas. LHC Atlas is a collider, which means that in the accelerator, the accelerated particles are collided to each other and create a new particle and detect them. But in this accelerator, the particle is not collided, but like this. Okay, I have to explain that. This yellow dots represent an electron. Electrons are orbiting the circular orbit nearly the speed of light. To contain the electrons into the circular orbit, they have to be bended by a magnet. When the electrons are bended by magnet, the electrons emit X-rays. The X-rays is represented by the blue dots. The X-rays are emitted toward the direction of the movement of electrons. So these blue dots are emitted to the outside of the rings. In this facility, the experimenter uses these X-rays. Basically, X-rays are a little bit difficult to create in our world. But in this facility, very, very bright X-rays can be utilized. The maximum brightness of the X-rays is, I remember that 1 billion times brighter than the sun. So you can use very, very bright light in this facility. Using such bright light, many experiments can be done, such as microscopic biology, physics, and so on. So there's so many kinds of experiments can be done in this facility. Okay, so let's move on to the experiment hall. Please follow me.
Okay. This is how big the place is. Open.
Are there everyone?
お疲れ様です。
Okay.
お疲れ様です。
すごい。
ああ、何言ってるかさっぱり。
もうわかんない。
Here is the experimental hall, and okay, you may find out that the roof is curving. This curve is sorry. This hole is shape of ring, as you find in the scaled model. So you can find that this hall is very big facility. The length of the circular
circumference?
Yes, is about 1.5 kilometers.
Is it 1.5 kilometers here as well? Like, is it 1-to-1? Will we actually need around 10 to 20 minutes to walk this by foot?
Yes, I think.
Yeah.
This is much smaller than the LH Atlas, but still big, I think. As George-san said, it takes about 20 minutes or 30 minutes to walk around. So there's too many bicycles here. So experimenter can use these bicycles to move around in the facility. Using a bicycle, it takes about 5 or 10 minutes to walk around here. Yes?
Oh, maybe I missed, but where is actually placed? Is it?
This facility is placed in the Hyogo Prefecture in Japan. It's about a little bit western part from the center of Japan. And also this is placed on the ground. I mean that this is not in the underground. So you can find this facility at this ring by Google Earth. So if you're interested in, please try to find it.
Yeah, because no collisions, no radiation.
Yeah.
I mean, a little bit of radiation as a treat. It's X-rays.
Yes, in this place, there is very, very little radiation because the radiation such as X-rays are blocked by the very thick hatch. The accelerator is placed in the white part over there. You can find a big white wall inside the ring. The accelerator is placed in that. And in the light yellow hatch, there is experimental instruments to use the X-rays. Okay, move into the hatch.
Here we
go.
How did I miss this?
This is one of the X-ray instruments. X-rays comes from over there to there. And you can put samples to experiment to here. And the X-ray detectors are put it on here. So in this hatch, you can measure the strength of scattering of X-rays. Using that, you can investigate the structure of crystal or proteins and so on. So using such instrument, you can research for example, the crystal structure of newer material or organic material and so on. This hatch is for such structural investigation, but another hatch is specified for another experiments, such as the structural analysis in the high pressure or high temperature. And another hatch is specified for the investigation for the X-ray imaging, and so on. So there is many kinds of experiments. Okay, then let's move and see around the another. Yes. Do you have any questions?
Yes. Can it be used in medicine?
Yes. To develop a new medicine, it is very important to know the structure of molecules. So to determine the structure of molecules, that this SPring-8 is used.
So in other words, like, you wouldn't be using this for medical X-ray imaging. You wouldn't just put a human in here and take pictures of their bones. But
don't tell that to Russians.
Okay.
Did they do it?
But what you would be using this for is like determining the structure of proteins using, say, X-ray crystallography, and then determining what sort of drugs you can use to interact with these proteins to get some desired clinical effects.
So cool.
So I forgot to say that when you put a sample to here, the X-rays are blocked at that time. Of course, without any blocking of X-rays, you were irradiated and maybe killed.
Wow.
When you put the samples here, then you get out from the hatch.
Makes sense.
Close the door.
And probably close the door.
Then the doors of the hatch is closed.
Yeah.
This doors has maybe 5 centimeter or 6 thickness made by iron to block very strong X-rays. After closing the doors, then there is no risks of the irradiation of X-rays outside the hatch. Yes.
So iron is strong enough to stop the ray? You wouldn't need like lead or something denser?
Sorry, I didn't understand what you're saying.
The iron door is is strong enough to stop the ray? You don't need lead?
This is strong enough. Strong or enough thick.
Okay.
It's cheaper that
way. This hatch is only one hatch we can see inside the hatch in this world. But SPring-8 has about 60 hatch like this. In each hatch, the experimenter can handle samples, X-rays, and so on. Okay, so let's move on to another experiment hatch. So please follow me.
So the whole thing is about having tons of these so that it can run experiments all the time. But
this is another one.
Like 4 particle colliders that do
The ID is 01B1. This is a similar hatch we saw last time, but it is much specified for the structural investigation. And the experimenter sit down here or stand by here. There is a controller to handle the samples or detectors in the hatch. So after the closing the doors, the experimenter uses these computer or controller to handle the samples in the hatch. And then they can use these crosses on the tables.
Nice.
In fact, there is much more much more matters on the tables in the real world, but it is very difficult to recreate in this world. So there is much less instruments on the table.
Makes sense.
To the move on to the next one.
Next.
Sometimes such large instruments are put on the hold. They are used in the they are sometimes moved into the hatch and I mean yeah, and such instruments are sometimes used in the hatch. So experimenters have to move these large instruments sometimes. Okay. And there is very many instruments on these shelves. And here is the vacuum pumps.
Vacuum pump.
It weighs like 300 kilograms, I guess.
Yeah, it's gotta be super heavy.
It's gotta be super heavy.
Yeah.
More than that. Depends on the material.
Okay. This hatch, this beam line is for the X-ray CD. CD, you may know CD in the medicated situation. I mean the someone using the microscope.
There's something there. Really?
Wow. Mama.
You can do a 3D X-ray scan of microscopic samples such as dust or small grain of sand in this hatch. So I forgot this is for it, but this kind of hatch is used for the investigation of the samples of asteroid from Ryugu or Itokawa. Okay, and maybe you can hear some kind of peculiar sound here. This is a sound of refrigerator. Refrigerator, but for the very, very cold temperature. And they are created a liquid nitrogen to cool down the detector. X-ray detectors sometimes have to be cooled in the temperature of about minus 150 degrees of Celsius or so. So they need to use liquid hydrogen. Liquid nitrogen. So this sound is to create the liquid nitrogen to cool down the detector in the hatch. Okay, then move on to the next one. Here are so many tanks of liquid nitrogen.
Oh.
Oh. Another thing that I should mention for context. Asagiri-san mentioned 2 asteroids that's had the sample material analyzed at this facility. Itokawa and Ryugu, I believe. The sample material from those 2 asteroids were brought home by the Japanese spacecraft Hayabusa and Hayabusa 2, which are perhaps the most famous accomplishments of the Japanese space program.
Yeah, we've seen them in the museum.
Yes. Yeah, that museum.
Thank you. Okay, the beam lines from here to the 2 or 3 another beam lines is used for the investigation of organic samples such as cells or proteins and so on. And the next one may be, okay, let's come here. Yeah, these beam lines are basically used by the Osaka University in Japan. So, in many times, the students of the Osaka University sitting down here.
This section specifically, or anywhere? It's like this
No,
is
this
their
section specifically.
See. Only one student?
Yes.
Okay. Special student.
That's enough.
Yeah, I think it is enough.
Yeah, so
Okay.
there are 2 types of beam lines. One is a shared line, and second one is a
You're already
reserved
lucky to
line.
get here as a student.
And it is
Almost
a
all
reserved
of
line.
the beam lines are shared lines.
Wow.
You gotta be really fucking good at your grades.
全部共用なんだ。
Almost all of the beam lines are shared by many many companies or universities and so on. But some of the beam lines are specified, and this is one of the specified beam line for the Osaka University. And I think the most fantastic beam line is specified for the Toyota.
Oh. Oh.
Car
Toyota.
maker. Yeah. Toyota is maybe using the beam line to develop the battery recently.
Solid state battery.
The battery for hybrid car.
Battery is very important for the electric car in near future, maybe.
どう思ってんだ？
This is all making sense. Convenient.
They are also providing cars to US so that we can put those machine guns on the pickup truck.
Apparently, your brother.
Them out in front using AI. Yeah, no, like in San Francisco they're doing that. They're putting the machine guns, they're putting AI in it so the car can just go and shoot.
So essentially Transformers. Got it.
Leave it to the Japanese to make Transformers a reality.
Okay, can we please pay attention here? Thanks.
Okay, so let's move on to the next one. I would like to make it the last one. this is the only one beamline using the infrared. I explained that the SPring-8 is a facility to use the X-rays, but not only the X-rays, but also the optical light, infrared, ultraviolet light are emitted by the accelerator. So they can use very bright infrared here. But of course, infrared itself is not so dangerous for human. But not only the infrared, but also the X-rays, gamma rays are emitted from the accelerator. So they should be use them in the hatch. Okay, so I have explained many beam lines in this facility, but they are only 1/8 of the whole this facility. So you can imagine that how large is this facility is. Today I don't have enough time to go around whole the facility. So if you're interested in it, please walk around and try to go around and back to the start point.
Okay,
so we're free.
Wait, no, you're not. No, you're not.
We have a free time. If you have any questions, please ask me.
Group picture.
You're free. You're free from him. You're not free from me.
What about group picture?
No, can I give some closing announcements before everything else? Okay, cool. So, thank you for coming to this event. I hope you enjoyed. Did you have fun?
Yeah.
Yeah.
Thank you.
Thank you.
What was your favorite? What was your favorite part? What was your favorite part? Somebody say what your favorite part was. Yes, Mike.
Everything about it, like from start to finish, especially in both worlds. Thank you so much.
Yeah, yeah.
My favorite.
I am.
Whole thing's great.
Yeah. I am glad that this went as well as it did. I suppose there were a lot of things that were not at all guaranteed, but I'm glad that we got good turnout and that it was an orderly process for everyone involved. But yeah, so VSP is a mostly Japanese group, so we don't have events like this particularly often. I think this particular English session is only something that happened because I thought to suggest it when I got called in to help Georgeus with his part of the planning on this event. We'll be doing a Japanese session next week for the Japanese VSP members, but yeah, I'm glad that you like it. If you wanna see more of this, let me know, and well, let any of us know, but especially me, I guess, because I do the most English events for VSP. News that may be of interest to all of you if you want to see more. Wait, like that. Oh dear. News that may be of interest to all of you if you want to see more things like this. I will be running a lot of English events representing VSP at VCAT 2026 summer, so 3 world tours, a presentation, and a space trivia game thingy. So that'll all be from, I think, July 12th to 26th, somewhere in that window if you're interested. Stay tuned for more news about that. I know there were some other Japanese events being planned for VSP, but I don't know exactly when they are. Also, other important things, I hope you have got a good sampler of certain things that we do. If you want to join the group, you can join with... Wait, where is it? You can join using this here thingy. This thing. This, like... this thing here. You can just click on it to join the group. Yes.
Japanese space program.
Yes. But yeah, I don't think there's too much else for me to say, but like VSP is amazing. They make so much just hyper realistic stuff like this, and I'm so happy that we got to do this event to try to share this stuff with English speaking audiences. But yeah, let's gather for a group photo and then back to Sagiri-san for any questions that you might have.
Do you also want to share the English group?
No.
English?
No. Okay,
No?
gather for a group photo somewhere.
I prefer to take the photo in at the spawn point. So,
Okay.
Oh.
Okay.
idea.
Respawn?
Respawn.
Yeah.
Respawn.
Okay, everybody respawn.
Wow.
Respawn.
Respawn. Oh, what is what? What? Wait.
Okay.
Hi.
Everyone
Hi,
respawn.
Respawn.
So 1 point.
Around there will be.
Oh.
Hey.
Cool.
Let's move a little bit, I think.
Oh,
no, the bike.
Wide. Ah. Oh.
Okay.
Yeah, there's enough room.
So we stay here?
I think yes.
Attack.
Maybe a bit.
I'll go back.
Okay.
There we go.
Taller avatar, stay in the back.
For you, I guess.
Yeah, let me scoot back a little bit. Yeah, there we go.
Okay, looks good.
Okay, makes sense.
楽しかった。
Okay, so then let's take the photo. 5, 4, 3, 2, 1. Cheers.
So many pictures.
Like paparazzi.
This is what it's like at every VSP event. There are like dozens of people cameras doing this. This is an important part of the VSP experience.
Memories.
Yes.
I think it's important.
You need memories and you need things to post on Twitter when the event is over.
Yes.
Oh my god, my bike is killing me.
We're doing important science over here. We need documentation. Yeah.
I mean,
Also, Kimica and Asagiri, I have something that I want to discuss with you too, so can you stay a little bit with me?
Okay.
Sure.
Endeavour-san, please stay with us too.
Okay. Have you finished?
I have to apologize for the trouble in the translation.
Then I also want one guy, one volunteer who can speak both English and Japanese.
You did very well, Asagiri-san. Thank you very much for your work.
Thank
you.
Yeah, this was very cool. I have no issues.
Yeah, thank you so much. That was pretty neat.
Thank you.
We will hold the Japanese version of this event in the next week. So please, if you're interested in, please join us. Thank you.
It will be on
what day?
July 4th, 2026 at 21 JST.
Yeah, because we thought that